next 30 minutes, we will be discussing some of the things that our company in-house product, we have the prototype on these two topics, right? So we will be discussing how the AI is helping in proactive maintenance of the network. Yeah, so already introduced, right? I will ask the Venkatesh to introduce.
I'm Venkatesh. I carry 21 years of IT industry experience into various technologies, unified communications, telecom, mobile, enterprise search, IoT, lately into AI as well. I've led the enterprise solutions in various domains, healthcare, insurance, banking, financial services, retail and energy sectors, and various customers in US, Europe, as well as APAC regions. So I'll be joining today along with Krishna. I'll be helping him through the sessions.
Okay, yeah, thank you. Venkatesh, can you please move to the... So who are we, right? We are the T2FD, right? And we have 23,000 professionals globally. More than 10,000 customers we have, right? And we are serving the customers in 19 countries worldwide. Most of the domain, right, is listed here in the left side. We are providing R&D and engineering services to tier 1 customers, right, in the telecom domain. We are also in the banking and healthcare and other sector tech services. Can you please? So coming to today's topic, right, we will be discussing two prototypes, right, two products, right, that we have, right, which helps the network operator all over the world, right, to maintain their network, right, and prevents the failures, right. So we will be discussing the two topics. One is the Copilot product, and another one is the smart log analysis tool, right, which detects the issues beforehand, right. So this is the network engineer Copilot, as the name suggests, right. It is assisting the operators, right. It is a event impact analysis tool, right. So suppose there are the large gatherings, right, in the town, and that needs the enhancements of the bandwidth, right, and other resources, right. Otherwise, there would be disruption in the services, right, or the quality of services will be degraded. And in some of the cases, right, there would be the full failures, right. To restrict those things, right, this tool is AI powered, right, which will give the operator the full data, right, what need to be done, right, if they have to cater a large gathering, right, which is going to happen in the future. Right, so for that one, we have a in-house tool that is called the CT-SIM. What is that? That is the traffic simulator tool, right, which simulates the traffic, what will be the real traffic happening in a city, right? So there may be the different domains, right, that need to be taken care of, right? So, such as the area, right? There may be the area where there are more buildings, right? There may be the densely populated area. There may be a less populated area, right? So different cases, different types of traffics will be generated for that case, right? Then there are the user categories, right? That some of the users are of the tender age, right? That they will be using mostly the mobile games, right? And some other things, right? But there are some older age people, right? They will be browsing the network, and there may be the different types of traffic generating by those. Then there are the activity types and the transportation means, right? That means some people would be traveling by car, some people will be traveling by train, right? So based upon all those 5 domains, right, with different types of traffics would be generated, right? So we have a inbuilt simulator tool, right, which simulates the different types of traffics that will be generated, right? And those data are used for training the models, right, different types of data, different types of traffics, right? And those are used for training the models, right? And the models also use the network configuration database and telecom domain knowledge to predict, right, which type of which type of actions need to be done for to prevent the failures and degradation in the services. Can you please move to the next one? So this is the overview of how the system works, right? So as the first step, right, operator queries the agent, right? We have the X event at the Y square, right, next weekend, and it is in the RAN network. Agent replies, right, ask, do you have any estimated number of the participants? Operator replies, unfortunately, no. Then the agent replies, no problem, we take it as a 1000 as an impact evaluation, which is the figure from the similar event that happened on the other square in the same city. Then agent queries, right, the model, right, ask for the prediction request, right, that we have the event at this address and this date and the number of participants. Then the trained model queries the RAN database, right, that which type of cells are there on that location, what is the cell's configuration, what is the which type of radios are there, what is the capability of the cells, right? And those type of informations are sent to the model again, right? After that, right, the model replies, right, what are the impacted cells, right, that will be impacted, right? And what is the predicted cell load that the model has, the information, right? Those information goes to the agents, right? Agent again queries the data, the RAN database, right? That to know about the configurations, right, and other things, right? That which type of radios is there, which type of configurations are there, is there a specific capacity there on that cells, right? Those type of informations are responded by the RAN database. Can you move to the, yeah. So RAN database response, what is the cell configuration, what is the status of the things, right? And is there a some hardware's capacity already remaining on those cells. Then again, the agent queries to the knowledge database, right? It knows, it already has now information about the data requirement, what are the spare hardwares are present on those sites, right? But it need to know with those hardwares, right, which are present and the additional capacity, right, how many users can be catered. Those type of information only be known by the data knowledge database, which has the knowledge of the RAN infrastructures and the capacities. And with that reply, right, after getting the knowledge database reply, agents reply to the customer, right, here comes the analysis result and proposed action, right? So there would be the full analysis result, right? So that even the operator doesn't have the full knowledge of the RAN equipments and other things, right? But they can go to the reasonings and analysis, right? And the proposed action, right? And that can, and then based upon their understanding, they can either schedule the proposed action or they can ask another query and to determine the things, right? So this is the whole anatomy. And yeah, so we have the demo for this one. The next would be the 5 minutes demo video for the same thing. Can you please?
Hello, everyone. As you know, large-scale gatherings triggered by social events can severely impact wireless network stability and mobile service quality. When the number of users far exceeds a cell's design capacity, issues such as access congestion, degraded service quality, dropped calls, and even equipment failures may arise. Our innovative RAN Engineer Copilot solution proactively addresses these challenges. It enables telecom operators to collect and analyze event data, forecast potential impacts, and automatically generate and implement remedial actions mitigating disruptions before they affect network performance. The Copilot offers two distinct modes, Chat and Explore. In chat mode, users can flexibly input and modify event details such as location, time, and participant numbers. Let us start the demo with chat. In the chat mode, the customer agent proactively guides users to provide key data required for network impact analysis. With its assistance, even users with no prior experience can generate professional network impact reports without the need for reference documents or prior training. In the demonstration use case, the customer agent utilizes visualization tools to present critical event data, such as event location, for user verification and modification, ensuring higher analysis accuracy. Leveraging collected event data, Research Agent first utilizes a pre-trained machine learning model to predict challenges in network traffic across relevant cells. It then integrates additional network data and contextual information to perform comprehensive reasoning and analysis, generating a professional report for user review. The current demonstration showcases an analysis report for the music talent show event. As demonstrated, the research report generated by the Copilot shows that our inference model comprehensively considers variations in network traffic, current network configuration and resource status, key characteristics of network equipment, and established network optimization practices. Moreover, the detailed reasoning process is accessible within the inference window, allowing users to review the analysis before approving the report. Once reviewed, the action planning module directly generates a network management schedule. Users can choose to execute the plan during off-peak hours, for instance, in the early hours of the night preceding an event, and then approve the plan for automatic execution. This workflow minimizes the impact of resource adjustments on active mobile services. Note that such a highly automated process requires a PR-level authorization for network elements. But what if an impending event is unknown to the user? The Explore mode provides an intelligent solution. Here, users predefine a geographical monitoring area and time range, much like a radar. The event search engine scans the internet for upcoming events, such as trade shows, carnivals, and more, extracting key details to generate an event list. Users can quickly review these events or initiate in-depth analysis via the research agent. Here then comes the research report for the selected event. So, how did we develop this prototype? We leveraged the citizen developed under an EU-funded project by us. This mobile service simulator replicates the behaviours and traffic patterns of wireless network users across an urban area. During prototype development, we deployed over 80 base stations in EMEA, Sweden, simulating diverse event scenarios at various city locations. This allowed us to collect essential data, such as user counts, self-report, and handover statistics, to develop and train our Copilot solution. In summary, the RAIN Engineer Copilot application can perform event collection, analysis, prediction, and solution generation days or even weeks in advance. This gives telecom operators ample time to upgrade hardware or allocate additional network resources to counteract event impacts, thereby enhancing overall network stability and service quality. Throughout our prototype development, we validated the inference model's solid understanding of wireless communications and its exceptional technical analytical capabilities, heralding a new era in intelligent wireless network management. Thank you for your time.
Okay, so and this product is already at the advanced stage. We are working for many of the customers for this one. Okay, before moving to the next topic, any quick questions on this one, then we can. Otherwise, we can move to the next one. Okay, so if not, then moving to there is a smart log analysis tool, right? That is we have developed, right? That is language independent, right? So you can apply it at any platform, anything, right? So that is called the system behavior analysis, right? Can you please go to the next one? So what is the traditional log analysis, right? The manual log analysis, there are large files, right? And, the people need to go search and those type of things, right? Troubleshooters have the limited knowledge, right? The people are expert into particular modules, right? Rarely some people have the overall system knowledge, right? So experts needed to analyze and take the accurate decision, right? That which module is faulty, right? Which is the root cause and those type of things, right? So this SPA learns the behavior from the logs and assists the end users in their troubleshooting, right? So how it has been done, right? You train the model, right, with all the positive cases and all the test cases that you have, right? And then you deploy it at the various places, right? You can deploy at the software update, right? You updated a new software, right? You collected the new set of logs, right? And then you deploy the SBA, right? And it will analyze, right? There is a difference between, there are three main domains, right? First is event analysis. Second one is the time analysis. And third one is the grouping of the faults, right? So it will check, right, what are the successful cases, right? What are the events, sequences, which type of events that need to come. If it finds anything difference, right, it will analyze and flag, right, that this has been not according to the original one, right? So there may be some issues, right? You can deploy this one into the continuous CI loop, right? Also will help, right? That every commit will be analyzed according to the with the right cases, right? And it will find the differences and notify quite easily, right? And then most important use of this one would be in the customer premises, right? Because the customer doesn't have the much knowledge about your our product, right? So if you put there, right, it will inform the any anomaly, right, in the counters or anything, right, before the customer knows only when the failure had already happened, right? So it can detect quite early, right, that there is something wrong, right, that is going to happen, right? Some events are not matching, some message sequences, the timing between those two messages are little bit increased by them in microseconds or something, right? And the curative actions can be taken before the fault has already happened, right? So as already explained, right, this is the event analysis. This is the one of the domain, right? So it will check, right, that when the events have happened, right, is there any change in number of events or the sequence of events? Those type of things it will analyze and flag, right? The second one is the time analysis, right? So time between any two events or two message sequences, right? So request went, but the reply is little bit late in the microsecond or something, right? You can configure the threshold, right? That up to this delay is acceptable. After that, right? You can flag the results, right? You can flag the alarm, right? So those type of things, right? That is the second domain it is working on, right? And the third one is, right, you apply this one into CI loop or some somewhere, right? Or maybe that in the fault tracking system, right? You can apply, right? So it will analyze the log, right? And it can group, right? That this type of fault has already been raised. It can make the duplicates, right? And it can also take the intelligent decision, right? Based upon the log analysis that where the this problem may be rooted, right? Which module it seems that there is this problem, root cause may lie, right? So based upon those log analysis, kind of root those things. Like generally, the organizations have this type of front desk, right, which checks the manually logs, right, and then based upon the analysis, right, they say that, oh, this seems to be this X module or Y module, right? But these type of things can be done by this tool itself automatically, right? You can attach it with your tracking system, your bug system, right? Okay.
That's too much.
So that's all from me today, right?